G'day and welcome to this episode of My Lean Business Coach, the podcast. Today we're doing some reading from your 7 Steps to a Lean Business book. It's been quite some time since we've been through this book, but today we'll be reading through chapter 4. So for those of you who have read the book, it's a good opportunity for you to have listened to it from the author. For those of you who've listened to the first 3 chapters through the podcast, it's an opportunity for you to catch up on the rest of the book now. But before we get started, if you'd like to really improve your business, then visit us at www.nlbc.com.au, where you can sign up for the free tutorials, our webinars, and look through other free resources. So now to today's topic, 7 Steps to a Lean Business, Chapter 4. This chapter is entitled To the Future. So welcome to the future, where we're not there yet, but we're getting there. At least that's the plan, right? Now, talking about plans, if you look at the PDCA cycle, we're still in the planning stage. As mentioned in the last chapter, the planning stage is often more than half of the project length. In this step, we're about to let our imaginations take over and begin planning where we want to be. Now, in this chapter, we'll discuss some of the tools that can be useful when designing the future state. I've chosen the word design to describe this process because the future should be developed from a clean slate, just as a new design of any type would be. The basic process followed to design the future state is outlined in diagram 4.1. So those of you with the book can look at the diagram. Otherwise, I'll talk you through what it actually means with this diagram. So we're looking for the ideal state. Develop a perfect process and flow with no barriers in mind. We're going to select countermeasures. So what can be realistically achieved now, and then go through resources and timing. And then finally, we're going to look at an activity plan. Actions required to achieve the future state with a detailed activity plan. So right now we're talking about the very top level, which is developing a perfect process and flow with no barriers. And we call this the ideal state. Not all lean practitioners use this step because they see it as waste, which in itself is against lean principles. But I see this step as more incidental work rather than waste or non-valuating work. You remember valuating work being discussed briefly in the early chapters. Now, non-valuating work and valuating work, incidental work, are very clearly defined. Valuating work is anything that the customer will pay for. Non-valuating work is what we term as waste. Incidental work is what we term as work required today to enable the valuating work to be done. So if we're looking at the process of making a business lean or implementing lean processes into a business, then value adding is actually getting the results. Going through the process of getting there is incidental work. Now, as I mentioned before, incidental work is any work that must be performed in order to complete the value-adding work. Just as non-value-adding work or waste can be reduced or eliminated, incidental work can also be greatly reduced. It can be difficult to eliminate the incidental work entirely due to the relationship, and it's usually eliminated by costly process improvements. Now, if we look at a dentist as an example of incidental work, this could be the application of cleaning paste to the cleaning tool. This application is necessary to complete the task, so it can't be classified as waste. However, it is not the direct reason for your visit to the dentist, which is about cleaning your teeth. Now, this could be reduced in time by relocating the paste dispenser closer and eliminating altogether by purchasing a self-pasting cleaning tool. But this can cost a lot more money, so make it practical as a solution. Now, through this, you may be able to understand why I see this step as more incidental work rather than waste. Without this step of creating an ideal state, it can be difficult to create the future state without allowing too many obstacles to obscure your view. The concept of creating an ideal state can be described as a dream state, as this needs to be developed with no constraints in mind. For this reason, it can be better performed by people with existing lean experience or people who are who are adept at free thinking and conceptualization. This step is also when some of the tools associated with Lean are brought into play. Now, most of these tools are designed to support and enable just-in-time delivery systems for materials. So the concept of just-in-time, or JIT, it came from a visit to the USA by Taiichi Ono of Toyota after World War II. It was during this visit that he found the answer to the problems that Toyota was having. Low demand after the war did not allow Toyota to benefit from the mass production systems being utilised overseas. So let's look at how a supermarket works. A product is purchased. This leaves a space on the shelf. The space is filled from the warehouse. This creates a space in the warehouse. An order is raised to the supplier to fill the space. Now, without being aware of it, the early supermarkets had developed a new supply chain method that would change the world of manufacturing. Ono took this idea back to Japan and Toyota and began implementing what is now labelled just-in-time. The objective of just-in-time can be best explained as a method to get the right things to the right place or person at the right time in the right quantity to achieve perfect flow of work while being still flexible enough to allow for changes in demand. Some of the tools created to assist in implementing just-in-time include a pull system. Now, to understand how a pull system differs from a standard push system, it's first necessary to understand how a push system works and the impact this has on a business. So again, we're going to look at the ACC cookie factory and looking at a push system. Now, this example begins at the flour hopper and continues only to the next value-adding process. As this example shows, the amount of inventory and waiting time between processes is very high. This is a push system of manufacturing. The product is pushed to the next process with no regard as to the current workload of the process. Now, in the example in the book, there's 11 steps. 3 of these steps are waste, 2 are value-adding, and 6 are incidental work. This equates to 27% of the process being waste. If we convert this to a value stream map, the waste is emphasized even more. Now, if we look at this as a VSM, of a total of 18,465 seconds for the process, only 415 seconds are value-adding, or incidental even. The rest is waste. The balance, which is 18,050, is pure waste in the value stream. That equates to 97% of the lead time for this process being non-value-adding. So a push system will generally result in a build-up of inventory between processes. This inventory can lead to many issues: poor quality, increased safety risks, increased scrap rates, poor cash flow as well. The way to control these issues is to introduce a pull system. A pull system usually uses some form of Kanban to control the pull of the product through the manufacturing process. The word Kanban is Japanese and simply means trigger. And it's usually a card, although these days there's more and more electronic Kanban coming into place. If you're a small business, then a standard card works just as well without the requirement for expensive software programs and so forth to maintain it. To simply explain, a Kanban is used to trigger something else to occur. So in the example in the book, in diagram 4.5, we're using Kanban cards and 2 corresponding Kanban boards. When the warehouse ship a part to the customer, the Kanban card for that part is sent to the production Kanban board as a trigger to produce another part. There are 2 main types of Kanban systems: withdrawal Kanban and production Kanban. Withdrawal Kanban systems utilize a supermarket of stock which is drawn upon. When stock is withdrawn, a Kanban triggers the part to be replenished. This system allows for reduced and planned inventory to be maintained. However, because inventory still exists, it may not be suitable where a great variety of parts are produced. Often in these circumstances, a supermarket of high volume parts is maintained in conjunction with other systems for low volume parts. Production Kanban systems operate in a similar fashion, however do not hold inventory. So when a part is required, a Kanban is sent to the previous process or supplier to manufacture or deliver the product. These systems allow for far reduced inventory, however they do require on-time delivery from all suppliers, both internal and external to work. It's a good practice to set up and use a withdrawal Kanban system for any high volume products and utilize production Kanban systems for lower volume or less critical products unless your systems to control the suppliers and supply processes are robust enough to ensure on-time delivery every time. Another tool that can be used is capacity planning, and it's titled Capacity Planning Modelling. And this helps ensure just-in-time is successful. To introduce capacity planning, you first need to know the capacity of your processes. This may seem to be stating the obvious, but it's surprising how often businesses try to implement this without knowing their capacities. The only way to know the capacity of your machines and processes is to measure their relative outputs. So what do I mean by relative outputs? This simply means to measure the outputs that are controlled by the cycle. An example of this would be a brake press machine. I often see managers measuring the output of completed parts from the processes, even though some parts have multiple bends. The only relevant measure of this process is the number of cycles completed per shift, unless you're interested in product mix. This actual number of cycles, when compared to the available capacity, will assist in identifying lost capacity. Most MRP and ERP systems enable capacity planning of some type. If you're not utilising one of these systems, a simple spreadsheet can be developed to assist with capacity planning. So back to where we came from at the start of this chapter, how is an ideal state developed? The most important thing to understand is that this ideal state must be free from as many obstacles as possible. Remember, anything is possible. If it seems impossible, then you just haven't worked out how it can be done. Look around you now and look at the technology that would have seemed impossible only 10 years ago. Free thinking is a skill that can be learned, and just like most other skills, the more practice you get, the better you'll become. Free thinking as an individual can be a difficult thing to master. However, group free thinking, whilst being more difficult, is extremely powerful when facilitated effectively. One of the best tools that can be used to facilitate free thinking is undoubtedly brainstorming. Brainstorming is a simple task, and it's a session where every person is encouraged to suggest ideas to fix a problem. It's important to make it very clear that every idea is a good idea and that all suggestions are recorded on the whiteboard without prejudice. Often the ideas will come from what are first thought to be far-fetched suggestions, and these will develop into the best ideas. As the initial idea is built upon by the group, these seeds can grow into great ideas. Brainstorming can be conducted formally and informally. When conducted formally, the process is structured as a mind mapping or cause and effect session. Each participant takes a turn to add a suggestion. The benefits of this structured approach is that all participants add value. The facilitator needs to be confident and experienced to get the best outcome. When conducted informally, then there is limited structure to the process. Participants are encouraged to add suggestions freely. The benefit of this approach is the team can quickly come up with a large number of ideas, but a problem is that one or more participants can hijack the activity. So an experienced facilitator is very important here and can limit the effects and likelihood of any hijacking. Now, during this process, it's important that the facilitator keeps the participants on track and that the team does not debate the suitability of any ideas or that intimidation does not occur. Mind mapping is a form of brainstorming when the ideas are written on the board. As more ideas are added, the facilitator begins to group the similar ideas together. Ideas that are built on others are shown in a parent-sibling relationship, a parent-child relationship. And mind mapping is best used when the team is working well together and the ideas are flowing freely. It's not a good idea to try and force this structure onto a team that's not functioning effectively. As a result, will likely be ineffective. It's important to work through the value stream when brainstorming for countermeasures and not try to find countermeasures for every problem area at the same time. This may take many sessions before the ideal state is finalised. Fix one problem area first, then go to the next. It's a good idea to have an area of the board boxed off to write down any ideas that come up that may be useful for problems other than the focus area. I quite often call this the parking lot. I'm always surprised to see teams getting bogged down during the development of their ideal state. This is a step that I get the most from, as I can challenge myself to find new innovative ways to overcome issues and also get great personal satisfaction in seeing a team that I'm involved with doing the same. So after identifying the countermeasures, there are a couple of ways to determine which one to use, assuming that more than one countermeasure has been identified. The first here is consensus. This can be useful for teams that know each other and have been working together for some time, but be mindful of groupthink. If you need more information on groupthink, then I suggest you go and do a quick Google search. There's plenty of information on Google around groupthink. There's also a bit of a blowout of this idea in the printed version of 7 Steps. The next one is multi-voting. This is a useful tool that has a number of guises. Basically, each participant is given a set number of votes to allocate to the selection of countermeasures. This allocation can be anonymous or open. Once all votes have been allocated, the votes are counted, and the selection with the greatest number of votes is the chosen option. Another take on multi-voting is the nominal group technique. This is similar to multi-voting, however, the options are entered into a grid and identified as A, B, C, etc. The participants then rank the options from 1 to whatever there may be as options. After all participants have ranked the options, the scores are tallied, similarly to multi-voting, but it covers off the whole gamut of options. Now, this process will continue until all the problem areas have countermeasures allocated against them. It's a good idea to regularly review the status of the project against your project scope, as it's very, very easy over time to veer away from the original scope. A good way to ensure the potential for this to occur is reduced is to use what is termed a parking lot, which I mentioned earlier. It's a separate list of open issues and new opportunities that are outside the scope of the current project, so you don't lose them and forget them. Now, after determining all the required countermeasures, a new value stream map, material flow diagram, process map, all those sorts of things are developed. Once that's all done, it's then time to get a little bit realistic. Now, remembering that all the above has been developed to be an ideal state. In most situations, we cannot implement this ideal state as there are likely to be resource issues that make some changes impractical. These issues may be financial, time, labour, and the list is never ending. To implement the improvements, we need to be realistic about what we can implement now. The reason we begin by designing an ideal state is that it's easier to bring an ideal state back to reality than to stretch a reality further. Now it's time to look at each of the improvements or countermeasures and assess them. So there's a number of ways you can achieve this. One of the most formal ways is to utilise failure modes and effects analysis, or Fmea. These can be used for process or for design. They were first developed by the US military, of all things, in the 1940s to determine potential failures in plans. Now, these days they're used in anything from designing small equipment, they're heavily used in automotive, heavily used in aircraft engineering, and also used quite extensively in process engineering as well. Another, less formal way, which is the way that is a lot faster and I'd like to get people involved in, is your simple cost-benefit analysis, which can be found on any Google search, so I won't go into it too much here. Once you've gone through this step here, then you have what we call the future state. So you go from the current state to the ideal state, and then you have the future state, which is going to be the reality of the current reality of the ideal state. So that is chapter 4 in a nutshell. So next recording we'll talk about chapter 5 in this book. Now, before we go, just a quick word from our sponsor. With Quick Procedure, it lets you create your procedures up to 400% faster than the original methods. It's available on iPad and on the web now. So you don't need a PC or a camera. You don't even need a notepad. Simply open Quick Procedure on your device, fill in document details, complete all the details for each step, adding photographs on the fly, all without leaving the process in the factory. Save time, save money with Quick Procedure. That's all for this week, and we will see you on the lean side.